Hello and welcome to the Data Lake Summit 2020. I'm Sharath. I am from Razorpay, a payments gateway solution provider from India. And here we are talking about one of the most intriguing topics as journey and the evolution of a data analyst over a period of time. And we call this talk the journey of a full stack data analyst 2020. All right, going through the agenda for the talk, I'll briefly talk about Razorpay and give you an idea of the scale that we operate at, both in terms of data and the things that we do. We'll briefly also talk on what an intelligence cycle at Razorpay is. Then we go over how the evolution happened across from being traditional analyst, data analyst at Razorpay, to moving on to become a full stack data analyst, right? And how we managed to bridge the gap. We also, in parts, talk about the journey that we embarked over a period of time and how Kubol in general helped us accelerate the journey towards the later part. And I would also go ahead and give you a brief on the way we leveraged some of these skills that we acquired over a period of time on a common platform to build what we today call as the merchant intelligence engine, and how being a full stack data analyst, right, helped us to achieve that at scale. Okay, who are we? Right, Razorpay is a payments gateway business at its core, and we have our innovative products that comes up are the business banking and the capital, Razorpay Capital, which are basically the business banking for the uninitiated is the neobanks of the world, but for the B2B side of things. Whereas we also help small businesses scale when they're in need of cash by providing working capital loans, and there are other innovations that are happening on the lending side as well. Payments is a core business. We process more than close to $1 billion or more than $1 billion of payments each month. Then that would also mean we also produce a lot of data over a period of time. We have moved from GBs to terabytes, now closing to petabytes of data. That means we are at scale, and at scale, things break. And when things break, we find innovative solutions to go through these phases. When we were scaling at Razorpay, we realized this life cycle is not for the data, but for the intelligence that the data throws at us. And hence, at Razorpay, we formed something known as the data intelligence cycle. We acquire data, our systems generate data, we have data stored in flat files, we get feedback data from different tools that we use across the board. All of this needs to be present and ready for people to consume in a way that actually helps them to make decisions. That's the journey from generating the data or having the data at your own end, and then moving it to a place by transforming it to meaningful information, right? That's the first step in the intelligence cycle. Then you use contextual information to convert that information into insights. Insights leads to a lot of actionables. Actionables are what you call pretty much the decisions. These decisions are plenty, and once you act upon one of these decisions, you end up with experiments, you end up with more insights, and that generates a lot of data. Then the whole cycle continues. So this is a vicious cycle. Now, as we started producing more and more data, we realized the time that is required to move from generation of data to getting the insight out of the data ended up expanding every day. We ended up with a lot of data at our own end, stored in various places, but that being converted into information and then deriving insights out of it became a bottleneck. When Recipe started to scale, there was a bunch of things that we ended up as our problems, right? So data was produced in large amounts, and the time taken for data to move from being just data to information to insight was ever increasing. This was the place where we needed to innovate. Before we go ahead and talk about how we crunch the time between data and insight, we will talk about what used to be the case when analysts started working at Razorpay at least 5 to 6 years ago. What is the role of an analyst few years ago, right? The stack that the analyst would know would generally consist of SQLs, Excel, and VBA, and very rarely the analyst would have the skills on programming languages. And of course, the BI tools would come in as a package with the analyst. And they mostly worked on traditional databases and warehouses with little knowledge on the technology that is powering these DBs or the warehouses. And they would always depend on the engineers or developers, both in terms of deciding how the data is generated and also the transformation that's required for them. So basically, the movement between being data, generating data, and then providing meaningful information out of it. So it was heavily dependent on the work of engineers and developers. And then they also had limited access to storage and computational capacity. So this would mean the time that was taken to move on from generation of data to insight delivery used to keep increasing as we had copious amounts of data that is being produced. And this ended up meaning that we were struggling to make data driven decisions at some scale. Come 2020, we were a scaled organization with a lot of focus on data driven decision making. That means we needed analysts who were superheroes. We needed full stack analysts who would transform the data that is generated into insights in quick time. That would mean they need to be self sufficient. The analyst would come with the package of having knowledge on SQL, big data, Python, frameworks like Spark, and of course, things that they could use, anything that they could use to make themselves self-sufficient. We are also helped by having our data hosted on big data lakes on cloud. That would mean we could stitch together things across the board. And with great computational power and storage, we also comes the responsibility of using it optimally, which would necessarily mean we need to look the kind of storage that we require, what are the partitions, what kind of computational power do we require, or what is the number of nodes and clusters that we require to scale things, and ensure there is seamless delivery of insights. We also ended up having a place where we could maintain readable code with sufficient version controls. That's the journey of, that's what a full stack data analyst looks like in 2020. Now, how did we end up bridging the gap? One of the primary requirements, as I said, we needed a distributed SQL querying engine for big data because we produce copious amounts of data and all of that existed on cloud, and we needed to stitch them together to ensure we get the right insights. So we needed something, a SQL querying engine that would be able to scan terabytes of data in no time. The second thing that we needed was unified analytic engines for large-scale data processing. This is especially true for building what we now call as mini warehouses, etc. This would mean we would end up building mini warehouses using frameworks like Spark to ensure that the complex transformations are not intensive of compute. Then we would also require a platform to author, schedule, and monitor workflows, which would basically mean if you have a sequence of things that we needed as to complete the transformation of data to insight, that sequence needs to be defined with dependencies, etc. System monitoring interfaces across multiple technologies or multiple stacks that we use, plug and play drivers across multiple BI tools because we needed to be agnostic of the platform that we are working on, and a unified view of cost and resource usage so that we don't go overboard on using the compute and the resource usage. The answer for that all thankfully lie in Kubol. So we were onboarded on Kubol a couple of years ago, and Kubol gave us the Presto querying engine, which is our distributed SQL query engine for big data. Then we had Apache Spark also built into the data lake platform, which helped us make compute intensive complex transformations on the cloud on the go. This would mean we could generate a lot of good insights and store them without a lot of hassle. Kubol had its own schedulers that were pretty user friendly for us to use in general because they were on the UI and intuitive. But as we scaled, we realized those schedules would also need to have dependencies, etc. And thus came Airflow with that. And Airflow was also embedded into Kubol, which helped us a long way in getting a view on how we can author workflows with dependencies and sequence. Kubol also helped us monitor the scale at which we need to work to ensure that there's seamless delivery of insights across the board by managing clusters, the number of nodes, and of course, auto scaling that's built in. Kubol has a variety of plug and play drivers. We ended up doing POCs across 10 different BI tools, and of course, ended up with choosing Looker as one of our BI tools. And they had drivers across almost each one of them. Unified view of cost and resource usage at scale, and of course, in times like this, we would look at optimizing for cost, and Kubol gave us the right way to do it by using what they call the cost explorer. And this helped us not only to reduce cost in general, but also to be aware of the cost that is associated probably at a query level too. This unified platform gave us the transformation that we required from being just data analysts who would throw queries at systems, get data, do offline processing, to getting a unified version of the data that is available for each and every person in the organization via other tools to consume and ensure that they're self-sufficient on their insights and the decisions that they need to take. How did we start out? Right, we work mostly on MySQL and PostgreDBs initially, and all of the transformation that we had to do that were complex and the DBs could not handle was done on Excels or Google Sheets, and probably rarely on notebooks offline. The data volume increased rapidly from being hundreds of GBs to terabytes. Our team size exploded as we brought value to the table. Then we ended up having a long list of analytics exercises that were just pending because of the systems that we had. And we needed to depend on the developers for every small change that we needed to do. Now, then we came about on the data warehouse part of it, where we tried and implemented data warehouses. We built and maintained connectors for BI tools for each from the warehouses. We ended with terabytes of data. So this transformation happened in about 2 to 3 months. The team size kept increasing. We ended up having few dashboards for the users. This gave them overview of the business. Then the dependency on the engineers still existed for any small modifications or creation of new warehouses. And yes, on the open data lake platform, that's Kubol, once we were onboarded, what helped us was we could get a single source of truth for all the data in the organization. So we ended up with all the data in the organization, including things maintained on Excel, Google Sheets, integrations with things like Salesforce, etc., all at one place, which would mean we could have end-to-end visibility of all the things that are happening at the organization. Build multiple mini warehouses and scale them. This is just the analytics team. Basically, we ended up writing queries, scheduling them one after the other to ensure that we can build a denormalized version of some of our data sets, so that it is one, easy to access, had a lot of meaningful information. This is also to the fact that analysts are context heavy, and with that context they usually end up helping and then writing code faster, though the code might not be really optimal. Write code faster for us to get from generation of data to insight generation. Then the stitching of data across events and multiple other data sources happened. We were able to, as I mentioned, plug and play across multiple BI tools, which also enabled us to choose a tool that would ensure that analytics teams were not the bottleneck for generating insights at the organization. What also happened was, over a period of time, we realized that with having something that has all the stacks that is necessary for us to do the work that is required to get to faster insights, we ended up learning newer things like Spark, PySpark basically, that we use to transform data at scale, which would mean things that used to take probably 6 to 7 hours using traditional methods now came down to under 30-35 minutes for the complex pipeline. As we scaled, this also enabled that the engineering team worked on the harder problems of creating platforms that are self-serve for people to work on, and we could concentrate on building ETL pipelines and things that are necessary for us to deliver insights. While we are doing this, one of the most stark examples of this transformation was in how we built what we today call as the merchant intelligence engine for the organization. We have roughly about 1,000 plus people segregated into different business units. We onboard a lot of people onto our platform day in, day out. In fact, thousands of people day in, day out. To get a unified view, or a 360-degree view as we call, was necessary for us in terms of both scaling the business as well as ensuring that we are compliant with the organizations that we work with. Of course, to make data-driven product decisions so that we solve for customer experience and delight our customers. All of this could only be done if we could stitch together data across the board. So initially, when we started off, when we were on the traditional DBs, we used to maintain a lot of our other attributes of merchants that we used to get from various sources in probably Google Sheets in an aggregated form, etc., and probably also on flat files across the board, where we could access with limited ability to stitch. So what happened was there was no feedback loop. That would mean all of this data would be stale at some point in time, and it would require an analyst to refresh the entire set of data over a period of time, which would probably take a week in general to get the feedback loop that is required. Like, for example, you run a marketing campaign and you want to know the immediate results, like probably what happened 2 days, 3 days, 4 days later. But this would mean the analyst had to spend a week on it, getting the data to meaningful sense, and then getting insights out of it and passing it back to the team that is handling the marketing campaign. From there, we went on to building what we call the most viable product, the MVP of the merchant identity. We ended up creating a lot of intermediate aggregates and derived tables to add the necessary attributes to the merchant. All of this happened with schedules that we were creating on Kubot using SQL queries. So there used to be a bunch of SQL queries that used to run between probably sometime in midnight till 6 in the morning, that would ensure that all of these things got stitched together and gave a denormalized table that had unified information of the merchant across the board. This ensured that all the people in the organization could get things at a day's delay. Moving on from there, the aggregates and derived tables started becoming larger and larger, meaning there were at some point in time, I remember there were close to 25, 30 aggregates and derived tables that we were maintaining across the board as schedules, which together became one unified view at the end of the schedules. Now, we realized that did not scale well, because one of the schedules failing at an instant would have domino effect on the rest of them. And hence, what we moved for having the single source of truth across multiple teams for this 360-degree merchant view and mining details at scale, we moved down from queries to writing some of these transformations on Spark notebooks, and then started writing Airflow DAX for our own selves, so that we ensured that we figured out the dependencies between multiple schedules and ensured some of these happened earlier or had the dependency so that the information would still be complete, and the retries used to happen automatically, as in required us to maintain readable code on our repos, etc. We came up with the whole workflow processes that enabled us to maintain the standards of coding that we now practice across the org. This in general has helped us scale our merchant base partially from what it was like an year ago to close to 5x right now. Today, the entire marketing team runs on this merchant intelligence engine. This also had other effects in terms of the risk team today depends heavily on this merchant intelligence engine for them to flag off fraudulent merchants. It also helps internal product teams reach out and roll out their products to the necessary cohort before actually going ahead and then scaling those products from 0 to 1 to scale. Thank you everyone for joining the session. I hope you enjoyed and learned a lot from the session. It was really great to be a part of this Data Lake Summit 2020. It's great to have a platform where data practitioners like us can share things and learnings across industries with each other. Kudos to the team that has done a great job on this. If you have any questions on the talk that we just had, you could ping me on the Slack channel or could ask me. Thanks, everyone. It was great talking here, and hope to see you guys next year too. Thank you.